starts with a raise or a fail. You know how to raise and rescue exceptions, but do you know how they work? And how to structure a robust error handling strategy for your app? Our next speaker is Amulya Tanksale, who will be speaking on exceptional Ruby. Amulya is an associate technical lead working with Sideband Technology Rails Factory. In her talk, the spotlight will be on error and exceptional handling, which will bring your exception handling techniques up to speed. Please welcome Amulya to the stage.
Good morning, everyone. In today's talk, the spotlight will be on how to improve exception handling techniques. First of all, I would like to thank RUBYCONF organizers for giving me this opportunity to talk here. So, let's take an example of a ATM machine. When you go to an ATM to withdraw money, you expect to get the money, right? But what if transaction failed? Money got debited from your account, but you didn't receive any money. It's scary, right? Why this scenario has occurred? This is because of poor exception handling. Whatever may be the reason for the failure, a robust program should have a good exception handling technique in place. Now, let's see more on what are exactly the failures, what should be the life cycle of an exception, how to respond to failures, some questions before raising an exception, and what should be your failure handling strategy. So, what do we mean by failures exactly? A failure is an inability of a system to satisfy its purpose. Let's take an example of a washing machine. So what is the purpose of the washing machine? To wash the clothes. But as you can see in these two images, in first image, there is a soap problem. Here, developer couldn't detect and handle it properly. In second image, washing machine could recognize and thrown the error code. This is because the exception was handled by the developer properly. So, none of can catch these chocolates. Why? Because you didn't expect this from me. So that was the failure, right? Now you can have some more chocolates. Yeah, that was the exception handling because you know that I will be throwing up, that it was expected. So these were the examples of the failures. So let's take a deep dive into life cycle of an exception. It all starts with a raise or a fail. Raise and fail are two Ruby methods which are defined on the kernel. These two are synonyms. We use these methods to raise an exception. Now let's see how to raise an exception using raise method. The full method signature looks like this. Starting with the raise keyword, followed by exception class, then the message in a string format, and the callback information in an array format. Raise can be called using number of ways, as shown here. When we are not passing any argument here, it will throw a runtime error or an active exception in it. In second example, we are passing an hello message. It will also throw a runtime error with a message attached to it. Similarly, each of these lines will throw a runtime error. Now, raise can be broken down into 4 steps. Let's see each of those in turn. First is to get the exception object. Raise uses the exception method to request an exception object. Built-in exception class in Ruby has defined exception method on both instance as well as class level. You can implement your own exception methods as well, as we know that every built-in method in Ruby can be overridden. Next step is to attach the backtrace to the object. This can be done using the setBacktrace method. Every callback trace is simply an array of strings. The first element of the array being the lowest stack frames, while the last element of the array being the highest. Each string is composed of 3 colon-delimited parts, that is file name, line number, and the context of that particular line. Third step is to set the global error info variable. This global error info variable can be represented by using this $bank sign. If you are not comfortable with this sign, you can also use its alias, that is $error info. This raise here is responsible to set this variable up. Then this global error info variable will contain the currently active exception in it. Once the exception has been rescued and not re-raised, it will reset this variable again to nil. Last step, once the exception object has been prepared, it will start unwinding the call stack. It will start looking for the matching, ensure, or rescue statement. If it did not find any matching rescue statement, it will simply print out the exception message, stack trace, and terminates the program with the failure status. Now that we know how to raise an exception, now we will see how to catch that exception using rescue. Rescue is simply designed to bring back the object to its stable state, either to retry the operation or to terminate it with the failure. Raise syntax looks like this, starting with the rescue keyword, followed by exception class, then the hash rocket, and then the variable to which the matching exception will be assigned. Raise can be called in number of ways, like we can pass multiple exception classes to it, or we can call it multiple times in a single begin block for different type of error messages. Now that we know how to raise an exception and how to rescue it, there are some ways available to respond to those failures. Let's see those in next section. Ruby is one of the few languages which provide retry facility in case of unreliable operations. For example, if an API is taking too long to respond, we can use retry. As shown in this example, here we are setting read timeout variable to 10 seconds. If an API is not giving response in 10 seconds, it will raise a read timeout exception. We are also matching it with the econf refused exception in case the API is being down completely. Then we are increasing the retries counter up to 3 as we want to try it for at most the 3 times. Here, retry is being called to start the begin block again. After 3 retries, it will raise the last exception in it. Whether the exception has been rescued or not, ensure block will make sure that the code under it will always run. Ensure helps to cleaning up the resources, otherwise they might be left dangling. Some failures are not that measure one. In such cases, you can check if the expected result can be replaced with any benign value. For example, in this code, if one date format is failing here, we are just replacing it with another date format. And the simplest way to report any failure to the user or the developer is simply using the puts. Sometimes, developer may want to get notified about the failures instead of halting the execution. In such cases, we can use a Ruby's warn method. Sometimes, we may want to get notified about the failures in some central location. There are few possibilities for that. that is a central log server, or you can send an failure report to the developer in email, or there are some third-party services available which you can use to post the reports, such as New Relic is available there. Sideband data. Every method has a primary communication channel back to its caller, that is return values. In case you want to report a failure without raising an exception, in that case you will need a sideband, that is secondary communication channel. In Ruby, there is facility of returning the multiple values. So we can return the multiple values instead of raising an exception. Here in this example, if user could not be destroyed, it will simply return the structure with attributes for user, status, and the message. Some failures are so severe that there is no other opportunity to fix it, and we have to end the program. We can do it using the exit. Here we are calling exit with the false argument. It will simply end the program with the failure code. Do you know that when we are calling exit, we are actually raising an exception, that is system exit exception. Now that we know how to handle and how to respond to the failures, the next question comes to our mind is, when should I raise the exception and when shouldn't I? To answer this question, there are 5 questions available that you have to ask yourself first. Let's see those questions. The first question is the situation truly unexpected? The classic example for this is user input. You can expect the mistakes. In such cases, instead of raising an exception, you can just give an opportunity to the user to try again and fix the problem. Second question, am I prepared to end the program? Remember, when any exception goes unhandled, it will end the program or the current request. In such cases, are you really sure that you want to end the program? Instead, look if you can replace the expected result with any benign value. Can I punt the decision up the call chain? If you are not so sure about whether the condition is expected or not, in that case, you have to ask yourself, can you delegate this responsibility to the caller? The great example available for this in Ruby is fetch method. Here, fetch method will take key and a block. It will try to find the corresponding value of that key inside the given hash. If it did not found that matching key, it will simply execute the provided block. Here, Ruby's or fetch methods creator could not decide whether the exception should be raised or not. They have given this responsibility to the developer to decide, depending on the condition, whether to raise the exception or not. So in this case, developer is deciding whether to replace the date with any benign value or to raise an exception in the second case. Am I throwing away valuable diagnostics? For example, you are about to get an result of a long-running expensive operation. In that case, do you really want to end the program because of just a trivial formatting error? If not, in that case, you can check if you can use sideband data strategy, which we have seen earlier. Would continuing result in a less informative exception? Sometimes, when you are failing to raise an exception early, it may result into a way that is less diagnostic. In that case, it is always better to raise an exception early than later. Now, let's see some more failure handling strategies. Have you seen a code like this before? This is nested begin block. Code like this are more difficult to understand, maintain, test, and debug. In this code, begin is code smell. But remember, Code smell doesn't always mean it is wrong. It also suggests that there is a better way available to do the things. In this case, the better way is to use Ruby's implicit block. Here in Ruby's method, at the end of it, you can just use rescue clause. And we are here isolating the failure handling logic from business logic, making the code cleaner and clearer. Some methods can destroy potential user data. Such methods are critical. You can't afford them to fail. In this case, you should have a better understanding of your method's behavior. Depending on the method's behavior, there are 3 exception safety levels. The weak guarantee. If an exception has been raised, the object will be left in a consistent state. The strong guarantee. If the exception has been raised, the object will be rolled back to its beginning state. The no-throw guarantee. No exceptions will be raised. It will be handled internally. If your critical method is not giving any of these 3 guarantee, then it means that your critical method is prone to failures. Be specific when hitting exceptions. Sometimes when you are trying to catch an overly broad exception type here, you will often spend long time just to figure out why this method is not doing what it should do. If you are not sure about the matching exception class, at least you can try to match it with error message. How to structure an exception class hierarchy? This question comes to every developer's mind at some point of time. There are some few possibilities available which can come to our mind, depending on which we can divide the exception class. First, depending on the module or the subsystem from which they are coming. Then, depending on the software layer, that is UI level failures or the model level failures. Then, depending on the severity levels, that is fatal errors or the non-fatal errors. Most applications, failure messages can be divided into 3 categories. User error. When user has done something wrong, usually can be handled by notifying the user about it and giving them opportunity to try again. The logic error. There is some error in the system, typically handled by notifying the system administrator or the developer's team and letting the user know that the problem is being looked into. Transient failure. Something is overcapacity or temporarily offline, usually handled by letting the user know about when to come back and try again. If these 3 exception types are there in your application, your 80% cases are warranted. And in this way, you are giving an easy way to handle all sort of exceptions. If you are more interested in this topic, you can refer these books. Thank you.